I'm Anna, I'm coach of Team NeuPro, and I'm pleased to introduce our team with our customer Thomas Neumeier, our project lead Sajad, and our enthusiastic developers Felix, Yannick, Jonas, Maria, and Jonas. And to give you a first impression of our project, we decided to show you our trailer, so please enjoy.
Hey son, it's me, Donald J. Trump. Eustace, you can't take our huge yacht. Somebody stole it. Maybe China or Mexico. Take our second yacht. It's the best second yacht ever. It's beautiful.
Hey, I have a suggestion for you. How about the Dirt Buster robot? It automatically detects the surface material, identifies dirt and damages, calculates a path, and cleans your boat. I will organize it for you once you get your girl.
Thank you. Thank you. This one? Perfect. So as you can guess, we are working on boats, and I'm sure we all know the feeling that now as the summer just started, we all want to take our boats and our yachts out. Sorry? Oh, okay, perfect. So yeah, we want to take our boats and the yachts out for the weekends now that the summer started. Okay, or maybe not. But there's a lot of people who have boats and they're super excited now that the summer just started, and they want to enjoy their weekends on their boats. But the problem is that there's a lot of work involved in making sure that you can take your yacht out safely every week. And if you don't do all the work, a boat can quickly look like this. There's a lot of seaweed and algae and shells that live on the hull, and that can get pretty dangerous. Then the boat might have to be stored in a dry dock for a lot of time. It has to be worked on. The work has to be manual, so there's no automation. And and it's pretty dangerous. There's a lot of dangerous and chemical substances involved in the process, and it can get pretty dangerous and health hazardous for the workers. Now, we identified the main cause of the process, the main cause that this process is so hard as the heavy maintenance, which stems from it being manually. The work has to be done manually, and it's super time consuming. Since the work is done manually, there's a lot of toxic chemicals involved, and it's dangerous for the workers. The time-consuming part connected with the manual work, it gets really, really expensive, and that can be very, very stressful for the owners of the boat and for all of us that want to enjoy the weekends on our friends' boats or on our own boats. Now, what we're trying to do is we try to replace this manual work with automation. In order to do that, our system needs to do three things. Okay, clicker doesn't work. It needs to be able to recognize the object it is working on. It needs to recognize the 3D surface of the hull. Then it needs to be able to create a plan what it has to do, and finally it needs to be able to execute this plan. Now from there we identified different requirements. First of all, it needs to be safe for the workers, and it also needs to be accurate because we don't want to damage these expensive boats. But then also we have to detect the 3D surface of the boat. We need to detect the material we're working on, because different materials need different tasks. And finally, we have to create a path so that we make sure that we don't miss any of the damages or the dirts on the boat. Finally, we want to offer the worker a way to track the progress, and the worker has to be able to exercise some emergency controls in case anything goes wrong, so that he can stop the process and stop the boat from being damaged more. Now, in order to give you a more detailed look of our system, I'd like to welcome Yannick on stage. Thank you.
Yeah. Thank you very much. It's on. Okay. Thank you very much, Jonas. So to give you a better understanding of our problem, let's dive into our structure. So we have our vessel, our boat, which has one particular surface. That could be, for example, wood, fiberglass, or metal. The surface can then have some dirt on it, like for example some mud, shells, or grass, like you could see on the picture before. And there could be some damages in the surface, like scratches, dents, or oxidation. So one vessel then has one particular work plan, which is generated by one or many cleaning controllers, what's our core unit. This cleaning controller then uses a camera as input or many cameras, and for the visualization a smartphone app, or could be many smartphone apps for many workers. And therefore we need some sort of detectors, for example, a dirt detector or damage detector. To execute the work plan, we then need one or many robotic arms. These are associated with tools that can be, for example, hammer, a brush, or a power drill. So this can then be translated in our system design. So we have 4 main subsystems. So starting with our camera subsystem. It consists of a 2D and a 3D camera, which generates a 2D and a 3D image. These 2 images will be then sent to our cleaning controller, our main unit. These 2 pictures then goes to our 3 detectors, the dirt detector, damage detector, and the 3D surface detector. We will then calculate the exact coordinates of the dirt, damage, and the surface, and send it back to our work plan generator. Here, we will generate the exact plan and send it then to our smartphone app for the worker to see what we have done. So the worker has here now the opportunity to either accept or decline the work plan. If the worker has accepted the work plan, we will send it back over our cleaning controller to our robotic arm. The work plan then can execute all steps step by step, for example, brushing the surface. So to give you even a better understanding how this works in real life, I want to welcome Maria on the stage to show you our real life demo of our Yama application.
So we start our app here. After starting our app, you have an introductory screen where you have some information for our user. Then you can start project. Then it automatically takes pictures of the object we want to work on. So let's start the project. Here you can see the working process. This is at now %, but it will change afterwards. Clicking 2D, you can see our picture, our car door we want to work on. You have some dents and some scratches there. Going back, you can also see the 3D image of the car door. Also, you have some additional information, for example, that the work plan was successfully created, and the material of the car door is metal. So unfortunately, we couldn't bring our robot on stage, but we will call our Sparks Lab crew. So hi Felix, hi Jonas. So in the control area, we have a play button to start the progress. So let's start the progress now. So you can see the progress is moving. We are now at 12%. The robot is already moving, doing some stuff on the car door. Some crazy stuff here. Or we get a notification that the task is harder than anticipated, so let's see what he will do. Only 20% are left. So now he is finished. So Felix, can you show us please what the robot has done?
Of course.
Oh, he has drawn a nice Mona Lisa, so I think we have to work on that. So I will hand over to Yannick again.
So thank you, Maria, for the great demo. I think you all could see that we have here a pretty cool system, but it's not really done yet, so let's jump right into our status of our project. So within the cleaning controller, we already done with the material detection and the 3D surface detection. Currently, we're working on the dirt and damage detection and the path planning for the robotic arm. Within our application, we have done the work plan overview, like you could see on the app, and displaying the 3D and 2D image, but we have to send the activity to the robotic arm. The robotic arm is not yet connected to our system. We're currently working on that, and that will be our next milestone for that. So I want to thank our customer, Thomas, for the great collaboration, sitting back there, and want to welcome our whole team, or part of a team, back on the stage. And yeah, thank you very much.
thank you for your funny and nice presentation. And I think we have later a little time to discuss a little bit. Thank you.